All right, everybody, this is Mr. Ainsworth again, and we are about to continue with going over the upper minus lower methods and also right minus left to find the area bounded by curves. In this case, we want to find the area bounded by the x-axis here, this cubic, and from 0 to 2, where this is 0 right here and this is 2 here. And what you first have to do on the cubic here is to find the x-intercept. So because you guys are expected to do this by hand, although I have a little advantage here. I did this using a software program. However, it's not too hard to do it by hand. What you need to do is understand that the leading coefficient right here is positive, so a cubic behaves a certain way. That leading coefficient is 1. And it's positive, so this cubic behaves like this, as opposed to the other way like this here. It doesn't behave like that. That it behaves when A is negative. And the third thing, or the next thing you need to do is find the x-intercepts, and that's simple too. So you just set y equal to 0, and you solve your cubic function here. So x cubed minus 3x squared plus 2x. Factor out the x, and you get x times x squared minus 3x plus 2. Keep factoring. That's going to be minus, excuse me. Minus 2 times x minus 1, where the zeros are 0, 2, and 1. And then here's 1 right here. So you're going to have 0 there, 0 there, 0 there. Sketch your cubic. Shade in your regions that you're looking for. It's bounded between the curve and the x-axis here. And remember, the equation of the x-axis is y equals 0. Alright, and then you go from there and you draw your rectangles in. You go upper minus lower in this case. Here it's going to be cubic minus 0, and then here it's going to be 0, because y is equal to 0 here, minus cubic. So the first integral is from 0 to 1, and the next integral is from 1 to 2. So your area in the first region here is going to be cubic minus 0, so it's going to be from 0 to 1 of x cubed minus 3x squared plus 2x minus 0. And then the next area is found by taking the integral from 1 to 2 of 0 minus your cubic, which is x cubed minus 3x squared plus 2x dx. So I'm going to distribute through the negative here. So in the first integral, we get x to the fourth divided by 4 minus 3x cubed divided by 3. 3x cubed divided by 3. These are going to cancel. Plus x squared. This 2x squared divided by 2 is x squared. We're just going to simplify this right now. On the second integral there, it's 3x cubed divided by 3, which is just x cubed. Why? Because the derivative of x cubed is 3x squared. So integrating each piece separately here, and then we need to evaluate from 0 to 1, and then add the second one. Now on the second one, the function after you distribute through the negative once, twice, and 3 times here is going to be the integral from 1 to 2 of negative x cubed plus 3x squared, minus 2x dx. So just keep that in mind, and then I integrate that. Okay, and so what is that going to be? It's going to be negative x cubed divided by 3. Excuse me. It's early in the morning, guys. It is 5:30 in the morning. Here I'm trying to do calculus here, and I just made a silly mistake, so let me fix it. X to the fourth divided by 4, right here, and then plus x cubed, minus x squared, all evaluated from 1 to 2. So let's see what we get here. Evaluating this first function at 1, I get 1/4 minus 1 plus 1 minus the whole thing evaluated at 0, so a big 0 there. Plus this whole thing evaluated at 2. Now 2 to the fourth is 16 divided by 4 is 4, so I get a negative 4 there. 2 cubed is 8. And then minus 4 there. And then I have to evaluate the whole thing at 1. So minus 1/4 plus 1 minus 1. Let's see what we get here. First of all, these opposites cancel out. 8, here the negative 8 right here cancels out with a positive 8, and those cancel out. So I'm looking at a positive 1/4 here, and another 1/4, so 1/4 plus 1/4 is 2/4, which is 1/2. And that's my goal. Okay, so my area in this one, bounded by the curves, is 1/2 square units. Okay, that's found by taking upper minus lower. Alright, next problem. Another upper minus lower problem, and again another cubic here. Getting a lot of practice with cubics. Can't go right minus left because you can't take the function minus itself using the horizontal rectangular method. So we want to find the area bounded by the x-axis again, which is y equals 0. Y equals 0, here's the x-axis. As you guys know, your cubic here, your x-intercepts need to be found, so if you're going to do this by hand, without the aid of a calculator or a graphing program, you need to find your x-intercepts, so 0 equals x cubed, minus 4x minus, nothing. And you want to bound this from -2 to 2, so here's -2 here, here's +2 here, and here's 0 here. You factor out the x, of course, and you get x times x squared minus 4. And the zeros there are 0 and plus or minus 2. So we have 3 zeros, one is -2, one is 0, and one 2. The leading coefficient is 1, so A is positive. That means it behaves like this here, as opposed to negative, it goes the other way. So you sketch the curve, you shade your bounded regions. You don't worry about the relative min and max, or how high and how low this thing goes. You just want to bound the area so you have a general idea of what's going on, and then so you can draw your rectangles in. So let me draw a representative rectangle here, and here you can draw it anywhere in the shaded region. All of that tells you is that the height is found by taking cubic minus 0 here. Again, there's your height, and the height is found by taking y2 minus y1, or in this case cubic minus 0, because the height down here is 0. So the height is going to be x cubed minus 4x minus 0. So it's upper, alright, minus lower. So in other words, just x cubed minus 4. And then down here, this other height here is 0 minus h equals 0 minus your cubic, x cubed minus 4x. Or in other words, h is equal to negative x cubed plus 4x. And the widths are just dx here, delta x. So again, height times width, that gives you the area. The integral sums them up from either 0 to 2 or from -2 to 0. So the area in this one is going to be found by taking the integral from -2 to 0 in this case of upper minus lower, which is x cubed minus 4x minus 0. And then add that to the from 0 to 2 of upper minus lower, which is 0 minus the quantity of -3x cubed minus 4x, which just turned out to be negative x cubed plus 4x, and then integrate that in respect to x. So let's see what we get. My goal is 8 here. So if you integrate that, you get x to the 4th divided by 4 minus 2x squared. 4x squared divided by 2 is 2x squared. Evaluate that from -2 to 0. And here, negative x to the 4th divided by 4 plus 2x squared evaluated from 0 to 2. Starting at the upper bound at 0 here, you get 0 minus, that's a 0, minus, evaluate that at -2 now, so you get 16 divided by 4 is 4, minus 2 times 4 is 8. Now the second one here, evaluated at 2, so negative 16 divided by 4 is -4. Evaluate that at 2, 2 times 4 is 8, and then minus 0, because you evaluate at the lower bound, you get 0. So over here you get opposite of -4. Over here I get 4, and then 4 plus 4 is 8. So step it out, don't skip any steps, alright, and you'll get your answer. Alright, I'm going to pause to take a sip of coffee here. Okay, this one here, what we want to do is find the area bounded between the two curves y equals 1, which is this horizontal line here at 1. There's a 1 there. And cosine y equals cosine of x squared. So what you do is you draw the cosine function here basically, and then you square it. And what happens is that all the values that were positive all the values that were negative down here in quadrants 2 and 3 become positive, because whatever you square is positive. So they jump up to quadrants 1 and 2. And it's not quite exact reflection because squaring doesn't do that, but it does make them positive. So that's why the graph only exists in quadrants 1 and 2, because y is always positive. And quadrants 1 and 2 only from 0 to pi. And then if you square all the values from 0 to 1, they stay in between 0 and 1, believe it or not. You can try it. You square 1/2, you get 1/4, and that still stays between 0 and 1. So if you want, check it with a TI-84, get your curves, and then bound, or find the region bounded between the two curves. Okay, so between the horizontal line and y equals cosine x squared from 0 to pi is in this region right in through here. Okay, what we want to do is take upper minus lower in this case. So you can draw your rectangle over here if you like, or you can draw it over here. You can draw it anywhere you like. But it's going to be y1, or y equals 1, with height 1 here, minus your cosine squared function. So your height, this is h here, h is going to be equal to 1 minus cosine squared x. That's going to be your height. Your width right here on this way is going to be your dx. And height times width gives you area. So what we want to do is we want to evaluate the integral from 0 to pi. So those are our bounds. Oh, by the way, how do you know it's from 0 to pi? So where a equals 0 and b equals pi, well, it says so here, but how do you know that they're intersection points? So again, let's find the intersection points here. Let's just go over that briefly, just because you're going to have to do this by hand. So you want to set 1 in, or substitute 1 in for y and solve it. So 1 equals cosine squared x. Okay, square root. You get plus or minus 1 is equal to cosine x. Well, when cosine equals, let's split this up. Cosine of x equals 1 when x is equal to 0, and cosine x equals negative 1 when x equals pi. Okay, so you have intersection points at 0 and pi. It's a little side note. You're going to have to do that, and understand that they actually intersect right there at 0 and pi. Okay, so we're going to integrate from 0 to pi of upper minus lower, so it's 1 minus cosine squared x. Alright, and this is going to be the area here, and it's going to be equal to, well, 1 minus cosine squared x. We know is sine squared x. Okay, so you want to substitute in. Okay, and we know what that is equal to. That's equal to x divided by 2 minus sine of 2x divided by 4, evaluated from 0 to pi. And you're supposed to memorize this integral. That was memorized in a prior lesson. Lesson 1.4b. Okay, right here, 1.4b, trig antiderivatives. Go ahead and take a look at your notes right there. That was memorized. Okay, so I'm not going to derive that again. You should just know that. And then we're going to substitute in pi first, and we're going to get pi halves minus sine of 2 pi, all right, divided by 4, minus 0 minus sine of 2 times 0 divided by 4. Okay, well, let me see. This is pi halves. Sine of 2 pi is a whopping 0, and that's a 0. So minus 0 minus 0. There you go. So the area is equal to pi halves square units. Okay, so if you have your basics from the prior chapters, well, then it's not too bad. If you didn't know what I knew right there, from here to here, actually let me highlight that differently, from here to here, then you're in trouble. Okay, so make sure you know your basics. Okay, moving on. Ooh, we're going to switch techniques here. We can actually solve this two different ways. It could be right minus left or upper minus lower. And let's see here. I'm going to go right minus left to start off with here because x is solved for, not y. So I'm going to show this technique here, and we're going to design our, first of all, we want to find the area between the two curves, which is this little sliver right in through here. Alright, and I'm going to design my rectangles horizontally, and I'm going to take the rectangles from y equals 0 here, because I'm going to write the integral in terms of y and not x here, from 0 to whatever this number is, and I think it's 1 based upon what I look at the graph here, from 0 to 1. See, my width right here is not going to be dx, my width right there is dy, so I'm going to write the integral in respect to y. And my height right here, that's h, is going to be my difference of the x values. So this is x2, and this is x1, and the width here, or the height of it, is going to be equal to x2 minus x1. Well, what's that? That's my parabola minus my cubic here. So this is let me see, this is my parabola, x equals y squared. And this is my cubic here, x equals y cubed. So I've got x squared minus x cubed. Y squared minus y cubed. So it's my parabola minus my cubic. That's my height of my rectangle. My width is dy, and notice everything is in terms of y. And I want to range it from 0 to 1. These are my bounds. This is a and this is b. Now why is it from 0 to 1? Well, let's just take this right here and let's substitute in here and let's solve the equation. Okay, let's find the intersection points. Let's check it out. So y cubed is equal to y squared, and that's the same thing as y cubed minus y squared equals 0. Y times y squared minus, let's factor out a y squared. Actually, let me change that up. Going a little too fast. Factor out a y squared, and y squared times y minus 1. The obvious zeros, or solutions, are 0 and 1. So 0 here, 1 here. So my intersection points are y equals 0 and y equals 1 right here, and y equals 1. Makes sense. Okay. So let's set up an integral in respect to y. So my area in this case is going to be the integral from 0 to 1. I'm going to write the function in terms of y because this is going to be right minus left methods here, although you can do it upper minus lower if you want. And I challenge you to do that too, because you'll find a different technique but yielding the same answer. But since both functions are written explicitly x in terms of y, I might as well do right minus left. Okay, so here we go. We're going to take my height of the rectangle, which is my parabola minus my cubic here, y squared minus y cubed, times my width. So this is a height, and this is my width. Height times width gives me area of the rectangles here, and integrating from 0 to 1 adds them all up. Okay, so I integrate here. I get y cubed divided by 3 minus y to the 4th divided by 4 from 0 to 1. I get 1/3 here minus 1/4 minus a whopping 0. And that's going to be 4 minus 3 divided by 12, which is 1/12. So my area is equal to 1/12 square units. Okay, pretty straightforward problem if you know the right minus left method. If you don't and you use upper minus lower, and I want you to check using upper minus lower, you're going to have to solve for y in both cases. But I noticed that a few of you did the other day, and you got the same result. So try it, check it both ways, or do it both ways to show that you have both skills, and you get the same result. Okay. Oh boy, we have a challenging one arithmetically here. So you draw your cubic, and then you draw your parabola, and you want to find the area bounded by the curves, which is, in this case, we've got this one here. Okay, and we also have this little sliver in through here too. I don't know if I can draw this that small, but we're going to give it a shot. That little area right in there. And we're going to take right minus left because that's the only way you can do it. So you're going to draw a rectangle here. And then you have to draw a rectangle here in the other one. Okay? And you have to go right minus left. Okay, so in this case, it's going to be, well, let me see, this is your cubic here. And this function here is your parabola. Wow. Okay, your parabola is your 2y squared minus 2y, and your cubic is your 12y squared minus 12y cubed. And you want to go upper minus lower. Now the height of them, let's talk height now, okay? The height of them is right here, and your width is dy here. Your height is found by taking right minus left, or cubic minus parabola. So in this case, it's 12y squared minus 12y cubed, all right, minus your parabola, which is 2y squared minus 2y. All right, up or right minus left. And the same thing down here, you're going to, on your second integral, you're going to go right minus left. But in this case, you got to be careful because it's going to be parabola minus cubic. So down here, your height of it, h, is going to be your, in this case, it's going to be parabola minus cubic. So it's going to be your 2y squared minus 2y minus your cubic, which is 12y squared minus 12y cubed. So it's going to be a different order. And again, your width is going to be your dy here. So let's simplify the heights. We've got 2y squared minus 2y minus 12y squared plus 12y cubed. Simplifying, I've got 12y cubed. Negative 12 and 2 is a minus 10, so minus 10y squared minus 2y. There's my height on that little teeny rectangle there. Up here, what do I have? I have height is equal to 12y squared minus 12y cubed minus 2y squared plus 2y. Distributing through the negative there, adding like terms, I get the height of negative 12y cubed plus 10y squared plus 2y. Okay, now you need to set up some integrals. Okay, now the intersection points. The intersection points are here and up here. Where are they? So what you have to do is you have to set the functions equal to one another, and you have to solve them. So you got to find your intersection points by taking this function here and substituting it in here and solving the equation. And because you're going to do this by hand, and you're not always going to have a calculator, so you got to verify all this stuff. You know, what are your bounds? What are those points? You know, what is this point right here? What is this? Well, that's obviously 0, but what are these points here? You got to find them. So we're going to substitute in. So we get 2y squared minus 2y is equal to 12y squared minus 12y cubed. Let's get everything equal to 0 here, and let's see what we get. We get 0 is equal to 12y squared minus 2y squared is 10y squared, all right, plus 2y minus 12y cubed. Okay. Let's factor out a y. So y, I'm going to reorder too. So you know what? I'm going to get everything, change signs. It might be easier for you guys. So let's change this up here. Let me start over again here. I'm going to change all the signs and reorder it here. Multiplying everything by a negative, we get 12y cubed, all right, minus 10y squared minus 2y. Now distributing out a y, I get y times 12y squared minus 10y minus 2. I should have distributed out a 2. That would have been a lot easier. So let me bring a 2 here and let's modify this. Let's distribute out a 2 as well and make it a whole lot easier. Okay, so let's try this again. So 6y squared minus 5y minus y. There we go. No, minus 1. It's 6 o'clock in the morning now. Okay. 6:24. All right. And let's factor this. So 2y times something times something. 3y here. 2y here. Let's see here. That's not going to work. Let's try 6 and 1. So let's see here, 6y and y, minus 1 plus 1. Let's see, negative 6y plus y is negative 5y. There we go. Okay, so what are the zeros? 0, negative 1/6, okay, and 1. Let's see if we get that up here on the graph. So negative 1/6 and 1. So we got 1 up here. This is at 1. This is at 0, and let me just blow this up and let's see what we got. It's hard to see this here. Yeah, okay, and there's negative 1/6. So negative 1/6 here. Let's go back out. Okay, so what we want to do is now just set up the integral. Okay, so here we go. The area is going to be, the first area is going to be from negative, let's say, 1/6 to 0. So negative 1/6 to 0 of height times width. So it's going to be your 12y cubed. This is in blue now. Minus 10y squared minus 2y. So 2y there. dy. That's the width. So height times width. Plus the one in yellow now, from 0 to 1. I'm going to do setup only here because I'm running out of room. You guys can finish the problem and you can check it with the result up here. From 0 to 1 of right minus left. So that'd be height, which is in red right here, negative 12y cubed plus 10y squared plus 2y times the width dy. Okay, and there's your setup here. And you go ahead and check this and check your answer. Make sure you're getting this right here. And if you can't get the fraction, just divide these two, get decimal, and check your decimal. And also do evaluate this on the T84 or 92, and check it numerically with a calculator. Check your setup by evaluating the integral on a calculator. Okay, and then check it with the decimal value of this fraction. All right, a lot of fun. Here we go. Let's try another one here. Actually, I'm going to pause here and come back to you in part 3.